Work Energy Theorem Project, Mini Mind Train Calculations. Section 1, Work. To first find work, we're going to do force divided by acceleration to get our mass. So we're going to take 21,200 newtons divided by 26.5 meters per second squared, and that's going to equal 800 kilograms, which will be our mass. Part 2, acceleration. To find acceleration, we're going to do force divided by mass. So you're going to have 21,200 newtons divided by 800 kilograms, which will equal 26.5 meters per second squared. Part 3, force. To find force, we'll do mass times acceleration, which will be 800 kilograms times 26.5 meters per second squared, which will equal 21,200 newtons. Number 4, finally we're going to find work, and to do that we're going to do force times distance. So you're going to have 21,200 newtons times 6.1 meters, which is used to find distance, which will equal 129,320 joules, which is the measurement used to find work. Section 2, kinetic and potential energy. To find kinetic energy, we're going to do 1/2 or 0.5 times mass times volume squared. So m is going to be mass, which will be measured in kilograms. Velocity will be v, and it will be measured in meters per second squared. So we're going to have 1/2 or 0.5 times 800 kilograms times 9 meters per second squared, which will give us a kinetic energy of 32,400 kilograms meters per second squared. Potential energy. To find potential energy, we're going to do mass times gravitational potential energy times height. M equals mass, which will be measured in kilograms. G equals gravitational potential energy, which will always be measured in 9.8 meters per second. And H will be height, which will always be measured in meters. So 800 kilograms times 9.8 meters per second times 6.1 meters will equal a potential energy of 47,824 kilograms meters per second squared. Section 3, work energy theorem. To find that, we're going to do force times distance equals 1/2 mass velocity squared. F is going to equal 35 meters, which is the measurement used to measure distance, and that's going to all equal 1/2 times 800 kilograms times 9 meters per second squared, which will give us 32,400 joules. We're going to take that number and we're going to divide it by 2. When we do that, we get 16,200 joules. And now we're going to divide this number by our given distance, which is 35. And that will give us our force. So when you do that all, you get a force of 462.85 newtons. So we just did that for kinetic energy, and now we're going to do the same thing but for potential energy. So once again, force times distance is going to equal mass times gravitational potential energy times height. And just a friendly reminder that F equals force, which will be measured in newtons, D equals distance, which will be measured in meters, M equals mass, which will be measured in kilograms, G equals gravitational potential energy, which will be measured in meters per second, and H equals height, that will be measured in meters. So when we do all that, we're going to do 800 kilograms times 9.8 meters per second times 6 meters, which is going to give us 47,040 newtons. Section 5, mechanical energy. To find mechanical energy, you're going to do potential energy plus kinetic energy. So we're going to use our formulas that we've been using all along this video to find these two things, and then we're going to put them all together at the very end. So for potential energy, we're going to have 800 kilograms, which will be our mass, times gravitational potential height, 9.8 meters per second, times the height, 6.1 meters. And all of that is going to equal 47,824 kilograms meters per second square. Same thing for kinetic energy, we're going to have 1/2 times 800 kilograms times 9 meters per second squared, which will all equal 32,400 kilograms meters per second square. Notice how both kinetic energy and potential energy use the same units as the n. That's going to be important when finding the mechanical energy. So now that we have our potential energy and our kinetic energy, we're going to add the two together to get a total or mechanical energy of 80,224 kilograms meters per second squared. And that, my friends, is how you find mechanical energy. Section 6, power. To find power, we're going to do work, which is measured in joules, divided by time, which is measured in seconds. So we're going to take our given, which is 129,320 joules, divided by 4.1 seconds, which will give us a power of 31,541.46 watts. And power will always be measured in watts. So say we wanted to add light bulbs to power, we're going to do what we already found for the first power, and we're simply just going to divide that by 100 watts of light bulbs. So when you do that, 31,541.46 watts divided by 100 watts, you get 315.41 watts. And that is how you find power.
So this is the Texas Giant calculations. So section 1 is work. The formula for work is force times distance. And in order to find your force, you have to do an equation on its own, which is mass times acceleration. So for this, the mass is 800 kilograms, and the acceleration is 37.4 meters per second. And the force, the answer for force is 29,920 newtons. And then from there, you take the answer from the force, and then you multiply it by 45, which is 1,346,400 joules. Section 2, kinetic energy. The formula for kinetic energy is 1/2 times mass divided by, times velocity squared. So 1.5 times 800 kilograms times 29 meters per second squared is 3,600,400 joules. The key info for this is mass, which is 800 kilograms, and the max velocity, which is 29 meters per second. The kg, the variables and the units are kg, which is kilograms, meters per second, and J, which stands for joules. Potential energy. Potential energy equals mass times gravity times height. The gravity is always 9.8 meters per second. So 800 kilograms times 9.8 times 45 gets us 3,052,800 joules. Section 5, Law of Conservation of Energy, which is the same as mechanical energy. To find that, you have to use potential energy plus kinetic energy. The potential energy is 35,800 joules and, plus 36,336 joules, which then equals 689,200 joules. J equals joules, PE equals potential energy, and KE equals kinetic energy. From the previous sections, you will find that the answers, the sum for potential and kinetic energy. And lastly, for section 6 is power. The formula for power is power equals work over time. So for this is a 3-step equation. So first you have to find the force, which is 29,920 newtons, and then from there you take that and you plug it into the work formula to find W, which then you get 1,346,400 joules, and then from there you take this answer and you plug it in to find power, which is 7,480. For the key info, mass equals 800 kilograms, distance is 445 meters, and acceleration is 37.4 meters per second squared. And the units and variables are right here.